Hello, my name is Rafał Sadowski, and I'll be giving a presentation on how to create NPCs perception system from ground up. So few things about me. I've been a game programmer for over 6 years in both AAA and mobiles. Most recently, I've worked as an AI programmer on Cyberpunk 2077, and I've worked there throughout the whole development cycle of the project. I'm mostly specialized in movement and perception system, but I also worked on other AI-related topics like AI behavior trees and general gameplay features. Currently, I'm working on some personal projects. I'm doing also some AI R&D, and I have no affiliations. So for whom this presentation is? This presentation is mainly meant for people that are just starting to write the perception system and they are looking for a good start point and a good overview of how to create such feature. However, if you are an owner of a perception system or if you are in the middle of development, I still think that you might find a lot of tips and tricks that will save you a lot of time and iterations. I won't include any implementation details here, meaning that I won't add any code snippets. But I think that with the concepts that I'm presenting and all the drawings, implementing this stuff should be fairly simple. And in my opinion, adding code to presentation when it's not needed makes it only less readable. Small disclaimer, even though I'll be showing a lot of screenshots from games I didn't work on, I did that because I want to show how common the perception features are present in different games. But I have to say that all the things I'll be showing worked for me in either personal or professional projects and are known as industry standards. Also, the human perception consists of different things like vision, hearing, smelling, many different senses. In my presentation, I'll be focusing mostly on vision because this is the sense that is mostly used in games. I'll be talking a little bit about hearing because I think that on this list, the hearing is on the second place, but there will be only one slide where I'll try to describe what's my development process of hearing feature in a game, but I won't go deeply into details. There are other presentations, useful presentations on this topic. One of them is Can You See Me Now? Building Robust AI Sensory System by Eric Welsh. And this presentation also tackles the topic of just creating a perception system in a game, mostly vision. I'll try to talk about different aspects of such process. But I have to say, if I would see Eric's presentation before working on my perception system, it would save me a lot of time. But sadly, I had to learn some things the hard way myself. Also, another presentation worth watching is Modeling AI Perception and Awareness in Splinter Cell Blacklist, done by Martin Walsh. And this presentation talks about perception in Splinter Cell also from a gameplay designer point of view and how to balance it and how to make it fun for the player. So yeah, this is a very interesting presentation and also it was very useful for me in the past. So okay, now you are in a point where somebody came to you and asked you to create a perception system, or you are there is this time in your project where the perception system is needed, so you're just looking for a way to start. So I always like to start with asking myself, when I'm creating any feature, what's the purpose of such system or what's the purpose of such feature from a gameplay point of view? And when we think about perception systems, we mostly think about games with stealth encounters like Hitman, but perception systems, this feature is present in probably any game that has some interaction between NPC and other objects. If you have combat in your game, if you have combat encounters, then probably you need at least some simple implementation of vision. And also, even if you're doing an adventure game where the NPCs can only talk with the player, still you will probably need to implement perception. Maybe it will be a lot simpler than the one in Hitman, but still you need something. So to answer this question, I would say that the main purpose of the system is to just give the NPC the ability to interact with other objects. But even though we answered the question from the gameplay point of view, I think that another step is to answer the same question, but from the technical point of view. And even though this might sound trivial, uh, I think that this is very important because this will help you understand the problem a lot better and find the better solution for your problem. So if I had to sum it up with one sentence, I would say that the purpose of such system is to collect the information for decision making, meaning that NPC just walks around or even is standing and just collects the information and notifies the decision making so that it can properly react or not react if we are not seeing the object. So when we start to think about vision and we start to visualize it, we mostly visualize it with a cone, uh, which goes from the eyes of the of the observer. And there are some advantages of doing that. If, for example, we project this cone onto a 2D map, then it's very intuitive for the player to understand that this is the NPC's vision and this is the orientation in which the NPC is looking. However, even though this is very intuitive, in most cases in games we are not using cones. For example, in this screenshot, you have a shape that is used in Splinter Cell Blacklist, and this is a coffin type shape. And also it has some additional shapes in the middle. There is a box, there is a cone, there is something that is responsible for peripheral vision. Obviously, Splinter Cell has complex stealth mechanics, so there is a possibility that if you in your game have only combat, then maybe a box is good enough. But if you have some stealth mechanics, then probably you'll end up with some more complex shape. If I'll had to pick only one shape, one simple shape that I had to use for doing this broad-based test, for doing this query, I would probably pick this, I like to call it a pizza type shape, and it's very often also called a pie type shape. And big advantage of this shape is that it's very easy to check if some position is inside it because you only have to do an angle check and a distance check and probably a height check, right? So it's rather cheap, and also this shape has very good gameplay properties because it's just well balanced and it serves its purpose very well. However, if you have stealth, then you might end up, as I mentioned before, with something more complex. And on this picture, you have something that, in my opinion, is most all-around complex shape built out of simple shapes. So you have the pizza type shape that I mentioned on the previous slide. You also have a cylinder in the middle because when, for example, the player is far away from the NPC but is directly in front of him, it's weird that the NPC doesn't see him. Player is expecting the NPC to notice him, but when the player is still in that distance, but a little bit from on the side, then the player is expecting not to be seen by the NPC. And also, you might want to handle the situation when the player is walking from the side, right? And for that, you have this box that represents the peripheral vision. And also, you have one more interesting thing. There is a sphere around the NPC, and this sphere represents the hearing or feeling sense. In many games, very often, when the player is walking closely behind an NPC, we want to punish him for that, so that he has to uh, act more quickly. So when he is very close, the NPC very often turns around. So to achieve that, you can just add this simple sphere around the NPC that represents the feeling sense. And I encourage you, when you are working and you're starting to implement the perception system, when you do this is called the broad face test, right? So when you start to implement the broad face test, uh, give the ability for yourself or your designers to create the vision shape as a list of simple shapes in a data-driven design, so that they will be able to iterate over it quickly and find the best shape that works for your game. Because uh, the thing that I'm showing is just an example that worked for me. As you saw on the previous screenshot from Sprinter Cell, their shape looked a little bit different. So you just need to test it. But when you have the ability to create your shape from a list of shapes, it will be a lot easier. So yeah, that the whole previous part was about how to create a broad face test and check if the position is inside our shape. But now, even though we know that the target is in the vision shape, we need to handle somehow the obstacles behind which the target will be hiding. In most games, this is just done by a simple raycast. And you have to remember that this part of the vision pipeline, the narrow face test, because if it's a physics query, this is the most expensive in terms of performance. So yeah, in most cases, it's just a raycast, but in my opinion, there is a better solution. So on this picture, you can see a picture of blinds. So just imagine that an NPC stands behind those blinds and the target is moving on the other side. So in this case, if you are using a raycast and also the mesh collider of the blinds is the same as the visual mesh, meaning that there is a lot of holes in this object. In this case, when the target moves, the vision will flicker because the raycast will move. The orientation of the raycast will move, and in small time frames, the NPC will see and not see the target. Obviously, you can solve that by, for example, changing the collider of this object to a box. But I don't like this solution because it puts more responsibility on the content team. And if, for example, you use a simple sweep test with a sphere where the sphere has 5 centimeters radius, the NPC won't be able to see the player throughout any object or any obstacle with small holes. You might wonder, okay, what if we want the NPC to see the target through blinds? I have a different solution for that, but I'll speak about it a little bit later. So, okay, we talked a little bit about the sweep test and that it might be better than a raycast. But if you have stealth mechanics in your game, and let's say that you're doing a third-person game where you can see the player, and the player is standing behind a road sign, and the sign is covering the player's head. In this case, the narrow face test will fail because player's head will be obstructed with this object. So you might have to use multiple narrow face tests. Maybe two will be enough. Again, this is something very expensive. So I would add as little of them as possible. Maybe only one test to the head and the second test to the pelvis is enough. And also, what's important, probably you won't need multiple narrow face tests to check the visibility between two NPCs. This is mostly used only to check if the NPC sees the player. Okay, so now we are in a point where we know how to do the broad face test, meaning that we know how to check if something is in our vision shape, and we know how to do the narrow face test, so we generally can do a visibility query. So I wanted to add a distinction between seeing something and detecting. And this is something connected to the human's perception. Usually when you see something running very fast in front of you, uh, and you see it just for a small for a fraction of a second, then you probably won't know what that object was. You noticed something, but you don't know exactly what that was or what that thing was doing. So seeing meaning that you can see it in that exact moment, but detecting meaning that you start to understand what you are seeing. In the example from the screenshot, you can see an NPC that is detecting a player in Uncharted, where the player is dragging an NPC, and you can know that the NPC is detecting the player because you can see the how uh, how the UI shape over his head is filling with a yellow color. In this case, it's fully filled, which means that the NPC knows exactly that he sees the player and probably he should engage into combat. So now I want to add another distinction on top of that, distinction between the detection value and detection speed. So usually the detection value is flowed from 0 to 100 and it's presented on in-game UI. If we go back to the previous slide, the detection value describes how much this shape over NPC's head is filled. When it's full, like on the screenshot, that means that the detection value is basically 100. And the detection speed obviously is just how quickly this value grows. And it's very often created from multiple components that are based on the vision shape, on the distance of the target, the observer and scene state and stats, and also the abstraction type. I'll try to go through all of them, all of those components one by one, and explain how they are created. But I also want to add that because detection speed is based on multiple factors, it very often ends up to be something like a detection equation that is based on those variables. So first thing is the how detection speed is influenced by the vision shape. You remember the previous slide of this complex shape I shown you. So yeah, when you have in your game a player that is moving around, probably you want it to be detected quicker when he's in the central vision rather than he's in the peripheral vision. Or maybe also you want to punish the player a little bit more when he's moving closely behind the NPC in that feeling sphere, so that you can set the speed for that specific shape a little bit higher. And also, a good thing to do here is to have the list of shape as a priority list, because in this way, the 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 shape that is highest on this list probably should influence the detection speed most. So if you want to punish the player for being just behind the NPC, probably the sphere will be first on the list. I would say that usually the things that will just give you the higher speed of the detection will be just the highest thing on the list. Another thing is how the distance of the target to the NPC influences the detection speed. So this is also something very natural. If you have something that is just in front of your face, you can detect it a lot faster. You can a lot faster understand what you are seeing than rather than when you have it far away from you. And in this case, you can just use a simple float to describe this relation. But if your game or your project allows to do that, I would use a function that describe this relation. On the screenshot, you can see a curve that exactly does that. So it describes how the detection speed changes in the based on distance. There is one additional trick here. Mm, I like to use something like a maximum distance for this function, meaning that everything that is further away than the maximum distance from you will use the value of the maximum distance. So on the example from the slide, when you have something that is further away from you than 30 meters, you will use the same value that is used at 30 meters. And this way, you won't have to handle some weird edge cases, and you won't have weird bugs where if you use just a simple curve, and for example, you have an NPC that is a sniper NPC and has a very big vision shape. Uh, when the target is further away, the detection will be very small. So to do that, you can just use the maximum speed. So learn how to we learned that the vision shape can influence detection speed, but also we learned about those distance detection speed based on distance functions. So in order to put it all together, you can basically create something called a vision preset, where you describe the set of shapes and you connect those shapes with the distance functions. So yeah, just remember that it's better to use a prioritized list. And also with this preset, you can use different presets for different NPCs. So if you have a NPC that uses mostly a sniper rifle, probably it will have a little bit of a different shape. Also, probably it will use different functions. If you have a civilian NPC, he might have a smaller vision shape and also lower detection speed, or just just a lower detection speed altogether. So yeah, if you use this preset, you can change it for different NPCs. You can have a different preset also for a boss NPC, so that he notices the player quicker and so on. So it's very useful. So also the detection speed is based on the observer and scene object state and stats. Here on the picture, you can see a player in Skyrim, and this player is sneaking around. He has a armor that probably adds some additional stats to his sneaking skills. So yeah, this also should be quite obvious that when you implement, if you create this detection equation, you should take that into account, or that you have to use also the state of the player, but not only that, you want to also use the state of the NPC, because the NPC, as I mentioned previously, if you have a boss NPC, probably has better detection stats, right? You might also have an NPC that has some mechanical eyes that allow him to see stuff from far away. So in order to have that in your detection speed, you need to take that into account. Another thing that influences the detection speed is the abstraction type. You probably remember the slide about blinds. And when I was talking about the sweep test for narrow phase test, uh, there was this issue that maybe the player, we want the NPC to see the player through this specific object. And in order to have that, in my opinion, the best way is to just set some annotation or some enum or some tag onto the object's material. And then when you are doing the narrow face test, you can just check the type of objects you're looking through. So you might have just three types of material: transparent, semi-transparent, and solid. And then when you're doing the narrow face test, you're checking that information and adjusting the detection speed based on that. So on this slide, I wanted to show you how to put it all together. So you can see that we have the vision shape, right? We have the preset I described previously, but also we added this connection between the materials and the distance functions I was talking about a few minutes ago. Uh, so when, for example, you have those blinds, right, and you have a target that is behind them, if the target is behind those blinds, but he's just 1 meter away, you will be probably able to detect him very quickly. But if he's even, let's say, like 3 or 5 meters from that object, the detection speed will decrease noticeably. So in order to cover that, in my opinion, it's good to connect also the material type to the distance function. And even though this preset might look very complex, uh, if you give yourself this ability to have those different presets and those functions, this is a very powerful tool in implementing the perception system. And this way you can save yourself a lot of time on refactoring your code. So okay, now we know how to create the basic broad face test, narrow face test. We also know the distinction between seeing stuff and detecting stuff. So what's next? The next thing I wanted to talk about is how to connect perception with other parts of the game. Even though this might sound simple, I think that this is something very important, because if you do it correctly, it will make not only your life easier, but also people that are working on other parts of the game, like the programmers responsible for the quest graphs, or the scripters and so on. So I wanted to give you few tips on how to make it more efficiently. So basically, the first tip is to provide a listener or event layer for the perception system. Your engine or your game might already have that, so it might be very easy to do. But if you don't, then at least write some simple listener listener class or something that will allow uh, any other part of the game to subscribe for perception events. And this will also add some additional level in abstraction, which is obviously a good. Uh, but yeah, if we look at the picture from the previous slide, this part is mainly connected to how the perception system talks with Quest or AI. For example, if you do this listener layer, later on somebody might add a Quest node that will uh, react to the fact that some specific NPC sees something, and that will, for example, in the game trigger a scene. With how it's connected to AI, where in AI I mean behavior trees and planners and so on, it's quite obvious, right? If the NPC sees enemy, he should probably react to that and do something. So another tip regarding connecting the perception system with other parts of the game is to give the ability to manipulate the state of the objects. And you remember the preset I talked about some time ago. So with this tip, I mean that, for example, you might want to be able to change the preset from scripts so that, I know, like the NPC uh, was uh, was hit it in his eye, let's say, with a bullet, right? So in this way, somebody will be able to just make the NPC blind or change the preset to a smaller shape. Uh, so yeah, that is very useful. And also another tip is to add the ability to perform an arbitrary perception query. So to give you some example of that, just imagine that you have a sniper NPC that is looking for a good position from which he can hit the player. So if you give the ability to perform any arbitrary perception query, uh, later, for example, somebody in scripts can just check if that specific position with some basic vision shape, we can see the player, and if so, then we can move there. But you have to remember that with great power comes great responsibility. So probably you'll have to add some limit so that later there is somebody won't just abuse this and try to perform many perception queries in the same frame, or you can just do it in a synchronous way. So when somebody performs it, he is not guaranteed to get the outcome in this specific frame, but he will need to wait for it. So then if you have a lot of them in the same frame, you can just try to distribute them over time. Okay, so we know how to create the perception system, we know how to connect it with other parts of the game. And the thing about the vision and visibility queries is that those are very expensive due to the narrow phase test I talked about. So probably if you have multiple agents in your game, and if you implement the perception system in a naive way, you will run into performance issues. So I'll try to give you some tips on how to avoid that and how to increase your frame rate. So first one is pretty obvious. You can see a screenshot from Assassin's Creed where you have a lot of agents around. So this advice basically means that you have to limit the number of agents that use the visibility. Uh, for example, if you have civilians in your game, maybe they even don't need to use visibility queries. It might sound counterintuitive uh, because obviously NPCs should try to act like humans, and every human is able to use his vision, right? But I encourage you to try even aggressively limit the number of agents that are using perception and just test it. Just check if that has some if that influences the gameplay in some way. And I can tell you that from my experience, when I was limiting the number of NPCs using vision, very often the gameplay effect was little to none. So another optimization technique is very much connected to how we as humans use our perception. And as you probably know, the human's perception is not instant, right? This is also kind of connected to the distinction between seeing and detecting stuff. We don't see stuff right away. There is small delay, even between the thing appears in front of a face and our brain records that fact. So we can take advantage of that in games. So you have to just give when you are writing the system at the very beginning, just give yourself ability to set some refresh rate on the visibility queries for NPCs. But you have to watch out for a situation where, for example, you spawn 10 NPCs with the same refresh rate in the same frame, and this will mean that still the visibility queries will be done in the same frames because they have the same refresh rate. So just remember about that and try to distribute those NPCs over time. So another optimization technique is just to prioritize. We know about the refresh rate, so we know that NPCs don't see stuff instantly. And there is another thing that we can use based on that. If, for example, just like on the screenshot, our companion is fighting with another NPC, they can have a smaller refresh rate between each other than rather when the NPC is fighting with the player. Usually the refresh rate for visibility queries against the player will be a lot higher than for visibility queries between two NPCs, because even in this situation from the screenshot, in combat encounters, very often player is so occupied by just trying to survive that he won't notice that the vision query from one NPC to another is a little bit delayed. But this is just one of the example. You can also have a smaller refresh rate for NPCs that are not in combat, or for example for NPCs that are allies. Those NPCs might not even notice each other, so maybe the refresh rate should be set to 0. So yeah, just remember about that and try to prioritize and change those refresh rate based on some gameplay aspects of the game. Also, another optimization technique is just to limit the number of narrow phase tests. In the example from the screenshot, you can see that the player is in a duel with another NPC, and in this specific gameplay scenario, we are guaranteed that the NPC sees the player. So in this case, we don't even have to do the visibility query. So we can assume that it succeeded. So if you can detect this, then you'll avoid doing a wasteful visibility test. But also another example for this advice is when you have two NPCs and one of the NPC did the narrow phase test, so he did a physics query towards another NPC, and it succeeded or failed, it means that if the second NPC will try to do the same narrow phase test, because they usually do it from the same position to the same position, right? They usually do it from their head to the head of the other NPC. In this case, you can cache that information that it succeeded or failed in the past, and you will be able to avoid doing it in the future. So you'll do it only once rather than doing it twice. Another tip is a little bit connected to the presets I talked about. So when we have our vision shape, the complex shape, we usually have only some limited number of presets that we'll be using, and either on the very beginning of the game or offline, we can calculate the distance for all the shapes. We can also calculate the bounding box for those shapes. So later on, when we have to do the broad face test, before that, we can check if the target is inside this distance or inside that box, and if it's not in that, if it's not in this distance, that will mean that there's no way for the NPC to see that object. So we can just avoid testing all the shapes one by one. Okay, so now there is the promised slide about hearing. When I start working on hearing, I have some fixed steps of doing that. First thing I'm trying to do is just to do a radius check. So when you have the NPC and you have a target, I'm just checking the distance between them, and if it's smaller than some set limit, then that means that the NPC is able to hear the target. Sadly, it will fail when the NPC is, for example, in another room, because he might as well be in this distance under that limit. So you can, for example, try to do a Raycast, but this will also fail in a situation where the target is behind a corner. So this is mainly used for games with very simple level layout. But if that fails, and if, for example, in your game you are guaranteed that the NPC and the player are always on the same nav mesh, then you can try to do nav mesh pathfinding and just check the length of the path. Uh, this, if you have that constraint, it's very good for you, because this simple test would handle that. But if, for example, the player you have some, verticality or in your level, and the player can be on a balcony, this will obviously fail, because even though the NPC can be close to the player, there is no short path, uh, so he won't be able to hear the player. So sadly, if that happens, then you'll have to do probably some 3D pathfinding, some audiograph, or some other way to check the connectivity between your interiors in your game. Okay, so now it's time for the last part of the presentation, where I'll try to just uh, give you some useful tricks. So yeah, first trick is to add the distinction between the observer and scene object. Uh, so it might happen that you will have some entities in your game that are only able to seeing stuff, like for example cameras, but they are not able to be seen by other NPCs. And also you might have objects that are able to be seen but cannot see, like for example dead bodies. In the case of dead bodies, you don't want them to do uh, visibility queries, because those are expensive. So if you want to save yourself some time or doing refactors, then it's better to just add this distinction at the very beginning. If you are working on an entity component system, then maybe you can have a different component responsible for seeing and different component responsible for being seen. But if you don't have that, you can just add a flag or two flags that will disable part of this functionality. And if you do it, even if at the moment you think that you'll only have normal humanoid NPCs that see and can be seen, if you add this at the very beginning, you might save yourself a lot of time. Another tip is when you are doing the narrow face test and you have your target position, where it's usually at let's say, the target's head. When the target is close to a geometry, because he's, for example, hiding behind a cover, then it's good to just move the target position a little bit from the geometry, detect that situation and move it a little bit for the geometry. Because if you don't do that, you can find out that it's very easy for an NPC to just lose the sight of the target. So yeah, this is also very useful. Another trick, imagine a situation where you have a patrolling NPC and he's moving his head around. You don't want to connect the orientation of the vision shape with the orientation of the head, because if you do that, the vision shape might move arbitrarily, uh, and uh, and it can rotate in an unexpected way. But on the other side, if the player is on the side of the NPC and he's doing some animation with looking around, you want the player to be noticed. So it's the best way to handle this situation is to just use some hybrid approach where you use the orientation of the head in some way, but for example, you don't use the roll, and you also add some damping so that it doesn't move arbitrarily. The last trick I wanted to mention is to give yourself in your vision query pipeline the ability to avoid the narrow face test. So avoid checking if the player or any other target is obstructed. And the best example for that are boss fights. If you have a boss fight and you have additional geometry on the level, very often you don't want the player to be able to sneak around and attack the boss from the behind. So you can just, if you add this, you can just disable the narrow face test for that specific NPC, for that boss NPC, and he will be able to notice the player in this situation. So okay, that was it. Thanks a lot. I wanted to also thank my wife for helping me out with all the drawings, and I hope that you find this presentation useful. Thank you.